let's practice applying solving right triangles to real-world problems. Angle of elevation and angle of depression. Those are terms that are going to be necessary for being able to set up the scenario where we have a right triangle situation. Angle of elevation. Think of elevate. Elevate like an elevator, to go up. It is the angle from the horizontal up to a line of sight. Versus angle of depression. Think of depress, like when you're feeling depressed. Or you feel down, looking down. Angle of elevation, looking up. So perhaps someone is standing lower than something and they're looking up towards something that is higher than they are. Angle of depression, perhaps someone is standing up high and they are looking down. The angle that is measured from the horizontal down to a line of sight. The thing is, it's always from the horizontal. From the horizontal. What does that mean? Well, wherever that starting point is, we start by looking across, making a horizontal line, and then the line of sight is the line looking up. That angle that's created is the angle of elevation. Being up high, you start at that point and go straight across, horizontal. And then looking down, that is the line of sight. The angle that's created, that is the angle of depression. Now, something important to notice in both of these is that as we draw this figure, it's going to be a right triangle. But what do you remember about horizontal line and horizontal line? Those are parallel lines. Therefore, we always will have this zigzag action going on, creating congruent alternate interior angles. Therefore, if we're standing up somewhere looking down, that angle of depression will be the same as someone standing down here and looking up at us, or their angle of elevation. Draw the same thing up here. You have this horizontal line and this horizontal line. There's the zigzag action going on that gives you congruent alternate interior angles. So my angle of elevation will be the same as somebody else's angle of depression. Let's now try setting up a couple of problems. The hardest part is figuring out what it's trying to say and draw the picture. Once you have the picture, you already know what to do. Number 4, a cat in a tree looks to attack a mouse on the ground at a point that is 12 feet from his position in the tree. If the angle of depression from the cat to the mouse is 40 degrees, how high up in the tree is the cat? So we have the cat up in the tree, looks to attack a mouse on the ground. So think about the mouse might not be directly below him. If it were, it would most likely be telling us so. So let's put the mouse somewhere over here. So the cat is up in the tree. Let's try to keep our pictures simple as we draw these. Cat is up here, vertical tree, here is the ground, the mouse is somewhere on the ground. A tree or anything vertical and the ground or anything horizontal will always be a right angle in the pictures that we draw. They might not be a perfect right angle in real life, but for estimation purposes, it will do the job. The cat looks to attack a mouse that is a point 12 feet from his position in the tree. So from the cat to the mouse is 12 feet. The angle of depression from the cat to the mouse is 40 degrees. So if that means from the cat, we start by drawing a horizontal line from the cat, and then where the cat would be looking, which is down towards the mouse. That angle is the angle that is 40 degrees. Now, if our right triangle is here, that 40-degree angle is outside of our right triangle. How do we get it inside of our right triangle? Well, one way is to remember the alternate interior angles, or the zigzag. So this 40 degrees is this 40 degrees. Remember that the angle of elevation from the thing you're looking at is the same as the angle of depression to the thing you're looking at. So those angles are congruent. Now we have that angle that's inside the right triangle that we drew originally. Here's our right triangle once again, and we know that angle. What are they asking us to find? How high in the tree is the cat? So how high up, that's what we don't know, that's what we need to find. So here's our picture. We know an angle, we need to find a side, and we're given another side. I'm mixing angles and sides, so what does that mean I use? SOHCAHTOA. Let's label from the angle that we have in our picture. So from this angle, opposite. From the right angle, hypotenuse. And then remaining is adjacent. Opposite and hypotenuse go with sine. So we'll write sine of 40 degrees equals x over 12, and now we'll solve for x. This time x is in the numerator, so we multiply. We multiply by the 12. So take our sine of 40 degrees equals x over 12, multiplying by 12 so that x is by itself. So let's go ahead and plug in our calculator, 12 times the sine of 40 degrees. Let's go. 12 times sine 40 degrees. I'm in degree mode, so it knows I mean degrees. 7.7. We'll go with rounding to the nearest tenth, since that's how the examples in the notes earlier were given. X is approximately 7.7. Now in word problems, our answers always have words. What do I mean? Well, first off, units. If this is a length, I look at the other length, I see that feet were used. So 7.7 feet. So we can say 7.7 feet high is the cat in the tree. Pretty cool, right? One more to explore. It is known that a hill frequently used for sledding has an angle of elevation of 30 degrees at its bottom. Let's start by just sketching that out. So I've got a hill. From the top of the hill to the ground, we assume is vertical, and the ground is always horizontal. So the angle of elevation of 30 degrees from its bottom is, starting with the horizontal, looking up, that is the angle that's 30 degrees. This angle right here, 30 degrees, angle of elevation. If the horizontal distance, horizontal means straight, right, and left, from the bottom of the hill is 50 feet, so this is 50 feet, estimate the height of the hill. The height of the hill is this right here, so we'll call this x. We don't know that. Let's go ahead and think about what we need to solve this. I'm mixing angles and sides, so that would require SOHCAHTOA. All right, let's label from the angle that we have to opposite and adjacent. Hypotenuse, there's nothing, so we won't worry about that. Opposite and adjacent is tangent. So we'll write tangent of 30 degrees equals opposite over adjacent. Because x is in the numerator, we multiply. X is 50 times the tangent of 30 degrees. Grabbing our calculator, 50 times tangent of 30, and I get 28 that rounds up to 9. So x is approximately 28.9. And of course, being a word problem, we need words, which means we need units. So how to answer? Estimate the height of the hill. 28.9 feet is the height of the hill. All right? Part A. Part B adds a little bit to this scenario. What does it add? Well, let's read. Jane is standing at the top of the hill. Okay, so if this is the top of the hill, Jane might be like this. The angle of elevation to the top of her head, angle of elevation to the top of her head is 4 degrees more than the angle of elevation of the hill. So if the angle of elevation of the hill was 30 degrees, and now we draw a line to the top of Jane's head, now this angle is 4 degrees more. So it was 30 degrees. What's 4 degrees more? That's right, 34 degrees. About how tall is Jane? So think about what we have right here. This nice, bigger right triangle. I'm going to draw that separately from our picture. We have the 34-degree angle of elevation and all the way to the top of Jane's head, and this is what we want to find. Let's call this all the way y. This is still 50, that horizontal. Now, we need to find this length because we need to know how tall Jill is. Sorry, Jane. We need to know how tall Jane is. So let's go ahead and find this vertical length. Remember, this is the top of Jane's head, and here's where the hill is from here down. We already know that amount. So y is that whole length right there. So again, opposite and adjacent makes us use tangent. But now it looks like this. Tangent of 34 degrees equals opposite over adjacent. So y is going to be 50 times the tangent of 34 degrees. Let's grab our calculator. 50 times the tangent of 34 degrees, and we have 33.7. So y is approximately, I'll write it over here, y is approximately 33.7. Now, that's the whole distance from here down to here, 33.7. Remember that earlier we found the height of the hill is 28.9. That's right here. So how tall is Jane? We have to find out how much just this length is from here to here. So all the way is 33.7. This part is 28.9. So Jane's height we get by subtracting 33.7 minus 28.9. And we'll figure out what that is. 4.8. Jane's height is 4.8 feet. And there we have it. Wasn't that fun?